I guess we're live. Live enough. So if you're watching and didn't have access to the chat, please say hi. Introduce yourself. Let me know if there's anything in particular you're curious about. But this stream will be about this device. So this is the keypad on top of a Raspberry Pi Zero. So if we flip it over, we see the familiar Raspberry Pi Zero. And I just accidentally hit a button, so it did things. So as you can see, there's a pink LED that is currently slowly fading. And that slowly fading is intentional. It's a neat trick I wanted to put in there. But it has some bugs that we should probably iron out. And what we want this device to do. So right now, these buttons do nothing. These buttons do nothing. But we have this, which increases the light. You can probably see it best on my face. So this is minimum light. So on a scale from 0 to 100, it steps 10 pieces of light, 10 units of light. And as you can see now, they're flickering wildly because I pressed them multiple times. It's a very terrible animation right now. Hey Tom, I think you're new. I don't think I've seen you around before. Welcome. This is the on-off switch for the light. So as you can see in my face cam here, the lights go on and off, and it makes a fair bit of difference for the camera. It's a good camera, so it doesn't crap out just because the light is low. But yeah, that's one of the things I want to work on. So I have two lights, and I want to be able to control them separately, which I can do with my Python script already. And the feature is built into my Keylight library, but I haven't built it into this thing. So I would like to, for this top row, to be controlling all the lights. This one be controlling the first light, the one I consider the first light. So that's up there. Let's see. That one. And the second one over there on this line. So on-off toggles, reduced brightness, increased brightness. That's what I want. Hey McBull, welcome. And then I'm thinking these should be light temperature. So we can control the kelvins of these lights. Let me know if the audio is okay. I've been fidgeting with it, and I realize it might be peaking a little bit when I do loud things. Let's see. I'll try not to clear my throat too much. So that's part of what I hope we will achieve during the stream. We'll see exactly how far we get. This is the light switch project. It's a nurse project. I can log into the light, and compared to last time, I can actually run Keylight Discover, and it should give us 2 lights. Perfect. Something I don't think we do currently is give those lights in a consistent order, which is something I would want the library to do. So let's look at that first, because I don't want them to accidentally swap places ever. So we query the DNS, we get some responses, records to devices. Enum map, enum reduce. Then it is a map. So maps are unordered. So what we would want to do is probably change how we address them in this one. So whenever we have, oh no, it makes sense to still do it in the Keylight one. Let's see. I'm glad the audio is fine. So I've actually changed the audio setup a little bit. I think I was using this one last time too. I have a big chunking mic that on a stand that I could bring in, and it gives slightly better audio. But this one lets me move around and not lose the audio. So if I lean down to look at the hardware and go out of camera, and I'm like over here, I can still talk. So it's a lav mic. It's on my collar. All right, so we have records to devices, but then whenever we do a multi, so I can show what that is. So if we get a Keylight discover, we can do keylight.status. The discover takes a little bit, but, and then it will run a status on multiple ones. But if we have just one, we could also just so this would give us just one element, and we should be able to. All right, then it doesn't want it keyed. So let's see. It would be element 1. And then we're getting that for just that one device. So let's look at multi. Just want to make sure that it uses a consistent ordering. So enum sort. That should be enough to give it a consistent ordering. So I can confirm whether sort works nicely on this data structure by just doing this. Yeah, and that's roughly what I'd expect. Neat. I'm also considering if I think it would be nice to unwrap. So I don't know if you saw, but when we call this, we get OK and then the data structure. That's not super elegant. It's also useful. I'm not sure if I want to unwrap that. All right. That's enough in the Keylight library, I think, for now. We'll have to revisit it if we want to fix the Kelvin thing. But let's look at the light switch. So I want to do controlling individual lights first. So we have this SPI LED order, and I've mapped those to line up with the same keys as we have for the GPIO pins. So we can detect a button press and we can connect that to a light. That's in place. And the way that we do actions for sort of a specific light, let's see, we can look at this. So we open listeners, can look at that. GPIO open and then set interrupt. So we want notifications whenever the GPIO changes. I think we can do ring logger.attach here. And if we hit some of these keys that are not bound to anything, we still get it logged that we hit them. So you can see that that key is 1, that key is 2, that key is 4, that key is 5. Sorry, I was about to sneeze. I did not want to do it into the microphone. All right. Let's see. What we can do here. So we get these events. That's handled here. This is the logging. If the value is 0, that means the button is pressed. And then we check, is there a function exported in the actions module for that key? This is a little bit of a simple way of doing the dispatch of these actions. I rather like it because it means I'm just writing some functions. So we have this one, which will check if any of the lights are on. And if any of them are on, it will turn them all off. Otherwise, it will turn them all on. So we can hit that one, and you'll see in the log turning off all devices. And my camera darkened a bit. And if I hit that, it turns them all on. Then we have these that adjust the brightness by stepping it an increment. And then we have this one which decrements it. I think we can generalize these a little bit if we want to, since we want to reuse them repeatedly. Let's see. Yeah, so this uses status to pull the existing brightness. That's why we're using status. Let's take this one, for example, and make FP brightness. Can do just devices. I don't think we need a state. We always want to operate on devices when we're doing this. So let's say that we want to increment. So this one uses, these both use max. Oh yeah, I want to cap. I do want to cap the increase as well. I don't think I can increase beyond 100, or rather, I don't think it's bad in any way. But this is, I think we should use something like that. Okay, so brightness, which is takes some devices and a change. We take all of this. We take the list of devices for each. Then we take the max brightness. Then we look at the devices again. And this is the increment. And we want to change that to change. So now if we gave a negative change, it should mean we're decreasing the light level. This should be enough for us to do brightness changes in a slightly simpler way. So let's do, this one is incrementing by normal incrementing for all devices. So then we should be able to do just brightness state.devices at increment. And then this one is the negative one. Let's remove all of that and just do minus increment. So that's these two. Now if I want this, so that's 5 and 8. I want 5 and 8 to do something similar. But I want them to take the first device. No, I want them to take one of the devices. Actually, let's figure out which device is which. D equals keylight, the devices. Now discover. And let's see. Let me take D. And we num.sort it. That's all good. And we pass it to keylight status. Does it work? Yeah, not really. But if we do enum.take one, does enum have a first? I don't think so. Enum.1, oh. Take one, get the head, so unwrap the list, take the first element, and we do that, then we get this. So we're going to be adding to the keylight that it will 151A is the one that will be first in the list. So if I turn that off, that's my second one. So that's the one I consider number 2. So let's call this light 1. Takes devices. And it will do roughly what we did. It will take the list of the devices. It will enum.sort them. Then it should, there's not an enum or list at last, right? Okay. And let's see. Yeah, that unwraps it. So I'll save a few commands. So that will be taking the list, sorting it, grabbing the last one, and then unwrapping it. Or, yeah, let's unwrap it like that. LM1. And that should be possible to pass to brightness. Actually, does that want... Yeah, it does. Status. Yeah, this will act differently based on the fact that I did that. All right. That's a little bit annoying. So when this is, when what I'm getting here is multiple devices, that's fine. But I would want to do it differently for a single device, which is not really how I intended it. What I could do is do the device and do light.status. Then we do each of those for each device. So if this is a list of devices, or if this is the map of devices, And actually I can just, let's see. So in D, we have those keys that we use for identifying a device. So let's pass the full list of devices. I feel like I'm complicating things, but actually, map take. So you bet I can do map take with an empty list as well. So because then we could pass the devices like we were doing before. So we can do all of this like we did before, filter, and then just map.take, filter. Oh, right, now it would, that would give me an empty list, right? Yeah, that's no good. That's the opposite of what I want. Okay. We'll simply assume it sends in a map with the devices we want. That's probably the easiest approach. And then if we want that, we do enum sort get list at last. And that will give us a key. Enum sort, enum reverse, enum.take one. So now we're grabbing one from the back of it and then map new. So we turn it into a map again. So this would allow us to, or let's see, what was it? Key 5. Let me know if you have questions. I'm always open to questions while I'm doing this silliness. Then we do state.devices. Write that through light 1. That should give us a new map, which matches the devices. And then we tell it to do the brightness thing. And then we do the same for K008, but with a negative. And now one of the simpler ways of trying this is the wild way, which is I cat this and then I copy this code and paste it into the terminal. Unfortunately, tmux not the best for that. So we'll have to do this. I think it's fine for the pasting. That should be all right. But I'll copy this. Tmux attach. Go down. Compiler undefined function devices. Okay. take a look at that. No, inside Tmux. All right, let's see. I'm using devices somewhere where I haven't. There. Oh, I have a spare. I have an extra K006, which I don't want, probably. So, which one is this? That's K006, K5. Down, up. I don't want to flip these. So this should be that and okay. So let's do this again. So it's fairly easy to also just burn new firmware and ship it to the device. Nerves makes that nice. But this is still faster for some type of work. Hold on, define function status. Status? Oh. Yeah. Remember what code you changed. Helps. I really should make a little bit of a script for the pasting part or for the copying part. So that should actually have updated that module. So now if we hit this, it should actually be hitting a code file. And now it did dim. I didn't bind K2. But I'm not seeing it do. It doesn't do anything now when I hit it repeatedly, so I don't know what that's about. Let's see. Set brightness. Gets the brightness. I can do logger.info. Changing brightness from red. Say changing brightness from 0 with -10, so that doesn't help at all. Changing brightness. So it is very dim, but I don't see any change. No, we still have D. So that's at brightness 10. We should be upping the brightness. Let me know if you see what I'm missing. From 0, that means this didn't match up. This is probably something with how we're doing this that isn't turning into what I would expect. Turning on both devices. Ensure that they're up. Well, it is trying. So let's see. I'm not getting the new login. Did I manage to not save it? Maybe I didn't manage to hit the copy properly. It's a bit of a... there are a few buttons to it in Linux. Oh, the IO inspect isn't reaching me. I should probably be logging it instead. So let's do logger.info. Because this is running under a gen server somewhere else, I would have expected it to print, but maybe it doesn't. Yeah, okay, so that... Right, I still need to strip the key here. That's my problem. So this doesn't match, and then it turns into a 0 value, which does not help us. And then it will always be a 0 value, and that's why it gets stuck at 10. That actually makes sense. I like it when it starts making sense. The good part is when this one is working, it's very easy copy and paste to take control of the next light. So, okay, now I can dim it all the way down and I can step it up. So now I'm all shiny. And back down again. Okay, neat. So let's add the ones for these keys. So 4 and 7. So then we need a light 2 function. That's the same without reversing. Also, we need to rename it. So 4 and 7, that's what we wanted. Let's run through actually making sure that works. 4 and 7 are in there. So that's dimming the heck out of my secondary. All right, and I want to do the on-off thing. This one is like unduly complex, honestly, but at least it's very, very flexible. So let's do the same thing we did with the brightness one. For devices. So it will go through the list of devices it gets, do keylight status, do this whole thing, figure out if it's on or off, and otherwise it will. So that would be simple on that one. So this is 369, then we could use two and do state devices, light 1, toggle. This should work, I think. And then we want to add here where it will be K1, hit 2. So without doing color temperature of the light, this would be all the functionality that I typically use day to day. So if we got it right, I'm pretty happy. All right, so turning both lights off. Now they're both off. Turning on the first light. Yeah, turning off the first light. Turning on the second light, nothing happened. Turning off the second light. It says it's turning on. Okay, it was at minimum brightness. So turning on and off actually worked. So it says it's turning on regardless. It's probably me that miswrote, but the toggle is working. So now I have full control over brightness levels, including turning on and off. That's nice. That's part of what I really wanted to get done. Hey Adolfo, welcome to the stream. Yeah, so yeah, this was why it's saying that it's turning on regardless. All right, bit of water, then we tackle maybe animation. I think the light temperature thing, like that's the least interesting one to me. So I'm holding off on that for now. I do want to fix the animation. So the issue we have right now is that if I hit one, it starts blinking around. Or if I hit multiple, it starts blinking around. And the reason for that is I made a very naive implementation of a way to fade the lights. So we have this feature for just fading light when it... The way it works is we set a certain light to a color and then we keep triggering new attempts at setting that particular color by sending messages back and forth, back to the gen server over and over again. That's a fine way of doing it, but we send just the same command. So if I just hit this, it will very slowly and very gently fade. can see it now. Soon it'll be gone. It fades at 1 step of color out of 225 per 100 millisecond. So, but if I do this, and then I do that, and then I do that, now it starts flickering because I'm setting all of the lights on every update, which is what you need to do with this light. But it doesn't, the different triggers don't actually know what the light state is because we don't keep that state around. And we absolutely could keep that state around. It's like 12 RGB, 12 pieces of RGB color. So in our gen server, colors, let's do that. And then so we should be able to do a 4 0 to 255 comma to 0, let's see, chameleon.rgb, I think. Chameleon.color.rgb, color.rgb. So that's a struct which we can work with. And R0, G0, B0. For chameleon color RGB struct is undefined. Huh. What does chameleon convert produce then? Because if we give chameleon.convert and tell it to do chameleon.color.rgb. Oh, we get a chameleon RGB struct, not a chameleon.color.rgb struct. Fair enough. So if we want to generate a set of those, this would generate our empty set. We don't need 255 of them, we need 12, so it should be fine to keep it around. Let's see. I keep forgetting. I think 256. So we just want 1, 2 through 12. Chameleon. Let's see. No color. Can I make a chameleon RGB struct as a module attribute? I don't remember. This would set them all up to be no color. Actually, these should be keyed off of these, so it would be SPI led order instead of doing this for loopy thing. We can just do enum.map at SPI led order key. Oh, that would be good as a for comprehension because we want to turn it into a map. Yeah, let's do that. I'm going back and forth a lot. I'm sorry about that. It's not the easiest to follow sometimes. But we're shoving all of this into a map, is the idea. And so that's key, and it's no color. That was correct. This should mean that we keep the state of colors around. And we can tell, this. No, I don't need a starting color. That's unnecessary. But then we could tell fade lights to, if it fades 255. So this is a little bit interesting. How do we want to specify that we want to fade a particular color? So rather than sending all of the color lights, I would say, and we're not going to do fill anymore. So we want to send the specific colors we want to control, but we want to not have to send all of the colors because it can use the colors from the state. So if fade's not 255, it will keep fading. And then it should go through the LED order. That gives us the LED, which means we can get the color that we want to work with there. Okay, so let's see. We want our base colors. Let's state the colors. And yeah, so we have state.colors. We want a final sort of color set to work through. So let's take state.colors and do map.merge. Just merge these colors down on top of it, which means we're overriding whatever colors you provide on top of the existing ones, but if you don't provide them, we will use whatever's there. And let's actually start there. So this would be the new colors. And then data equals, and instead of going through the SPI LED order, now our color set here should have every key. So that will be the LED and color. We can ignore that. We don't have to do conversion because we're already working RGB. So we can call this RGB. And the fades is the number of times it has faded, which is how much it will cause it to like dim out. So this should now be I think this should return new colors. And if it is here, it can just return state of colors. So now it always returns whatever the color state is. Here it sends the color updates. So skip the fill. Yeah, so I think that will work. And now when it gets this, skip the fill, track the fades, do that. And now, anytime this is called, it will return new colors. And then we can update the state to set those colors. And we also need to change then where we're using this. So the key should be chameleon.rgb. So we want the red to be 255. We want the, if we want pink, that is. I actually want to do cyan right now. So green, 205, blue, 255. That should so this will now return the new color. Else save.colors because this will do that too. So let's update the color so it knows what's up. Let's see if this works. In this case, there's a gen server that's changing. All right, I need to export the target. Oh dear. Yeah, okay, so I have some dependency stuff I haven't dealt with. Let's just override the dependency. We're running on mDNS Lite, which is on this version, which is fine. That's from when I was bug hunting. Unexpected comma 68. So we could do this in a slightly readable way. One-liners, they're very rarely helpful. Sometimes, not as often as we tend to use them. I think this is the poor syntax. I never remember properly. "95 undefined function colors." Oh, right, new colors. Oh, right, that caught a mistake down here as well. That would have been port. So now we're building the image. Now let's upload it. That one. So sending the image over SSH. Nerves will do some rebooty booty. And we'll be back running. So I'll do pinglight.local, which should tell me when it goes down for update and when it comes back. It's funny because ping will keep working and trying if it succeeded initially. But if you're pinging something that was never up, then it won't do it. So now it claims to be up. Doesn't necessarily mean that it's responding to key commands yet. So now it's responding to key commands. I'm not seeing that it's setting the color at all, which means something's probably not working right. Maps merge nil. Okay, so we have a bug. Find it. So data colors. Here we have state. Oh, that's a heck of a thing to set something to. Did it? There we go. Mix firmware. So if we have this gracefully animating and me controlling these lights individually with it, I'm very happy with the outcome of this stream, because I actually use this daily already because the toggling on and off for lights is nice. But I keep wanting to adjust. So one of the reasons you want to adjust your lights that much and that often is just due to, okay, so right now it's down. But the lights from my window change throughout the day. And that leads to changes in, how the lighting should be done if I want a good picture for the camera or whatever. And it's also nice to be able to tune how bright they are in my eyes as we go through the day. Okay, so, well, it set the wrong light, so that's unexpected. It's flickering a little bit, which I guess is to be expected when we have multiple things fiddling with it like that. So maybe I need to unify it a little bit. Put them on sort of the same cycle. But I'm surprised they're flickering. I don't think... Oh, there's a ton of details I'm not taking care of right now in this code. So when we're running the fade, we should only be fading the color. So if LED, let's see, if colors LED is nil. Well, nil actually is a falsy value, so if we are dealing with the color where we're supposed to be fading, then we fade it. Otherwise, we should just be writing the straight color because the only thing we're trying to do here is maintain whatever color is there, so that when we update, we're only fading the one that this fade lights call is actually asking us to fade. So that makes sense to me. Why that would be weird. It will lead to fighting, like, oh, we faded all the way to 5, and I'm still fading up here at 200, which would lead to very peculiar behaviors. So if anyone else is watching and hasn't said hi in chat, please do. And if you have questions or wondering about something that we're doing here, don't hesitate to ask in chat. I do keep an eye on chat, and there's a slight delay, but nothing too serious. So please do talk to me. And I'm always curious to get feedback, both during streams and after, about what people would like to see. So I do all sorts of Elixir during the day, typically web dev stuff, and this is more fun experimentation time. So then here I play with some hardware, some other things. But yeah, if there's anything in particular you think would be fun or useful to see streams about, let me know. I'm always curious. So the fact that we're hitting the wrong ones, that's not a huge problem. And the flickering back and forth, so I think that gets worse if you hit the same one repeatedly, maybe. It's a little bit funny. It's not doing exactly what I intended, or it's not working exactly as I intended, but it's doing pretty well. I'm surprised that they don't line up though. So I think I'll have to keep working at it to actually get it where I want it to be. But it's pretty good. It's all right for for what I need. It's a little bit funny just how it randomly colors and uncolors. So yeah, something to look at. Maybe just simplify it and have the light go on for a few seconds and then turn off when it's been, or just turn the light on while you're pressing. It's also a variant. But the feature set is where I want it to be, which is I can control these lights. I can adjust these, the brightness. That's pretty much what I need. So what I would do right now is just comment this out, because the flickering can get annoying while it's standing on my desk. So for now, sorry colors, you're out for now. But I do want to make something neat of that. There's a ton of fun stuff you can do. So the Chameleon library, actually, I'm not using it to nearly its full potential, but you can do a lot of fun with, if you have color RGBs like this, if you have HLS color space, color. So that's hue, saturation, and lightness. Yeah, let's look at these. There, this thing. So if you put yourself in the 50% luminosity, smack in the middle, max your saturation, and then fade. So then hue is 0 to 255 across this color spectrum, which means you can just go increment in color every few milliseconds and work your way through the entire rainbow of colors in a very nice way. Actually, I can go for a little bit longer and we can actually see if we can do something fun with that. So we can use set lights. That's a simple, it's very good for filling. Let's just do an interval. So let's send at a 200 millisecond interval, maybe 100-second interval. Shift. We send ourselves the message shift and copy this and just go shift. Don't care about that. Set lights. We don't set any there, but we send a fill. And now, if we want to use Chameleon to do this, that's very helpful because we might want HSV. Is that what they're called? Or, well, I don't actually know the difference between, I guess this would explain it. Hue, saturation, and lightness, and hue, saturation, and value. No. Yeah, so HSV would be, then we would want 0 typically. Fine. So let's log into the device. And if we do, have I exposed set light as a public function? Please tell me I've done that. I don't think I did. Okay. Then we can't really try it easily. So if we, this will take any color we get in and turn it into RGB, which means we can use chameleon dot color or chameleon dot HSL, set it at, what are the ranges? 7, 8, 9. So typically I imagine it will go 255, but I'm not sure. Non-neg and integer, yeah, that's good, but yeah, let's do that one. So we pass it this color. And for hue, we want a special value. Saturation, we want, don't know if this one wants like 100% or something else. So that we can actually pass chameleon.excel.new. So hue, let's do 300, 50 and 0. Okay, it doesn't complain. Still think it's based on 255, that's typical. Actually, would like to know the number. Hue is a degree on the color wheel from 360. Huh, wasn't aware. Well, it will still accept that. So saturation is a percentage value. We want 100% saturation, and lightness is also a percentage value, so we want 50, just in between light and dark. And to get the hue, so let's assume 360 is the range. We would like to base that off of something that's based on time. So oh, Erlang was not compiled with docs. Well, gee, thanks. Erlang monotonic time. Actually, I think Alex just exposes that system monotonic time, right? And we can. So we can do system.monotonic time. Like that it starts at an unspecified point in time. So let's see. Math is not my strong suit, but I want to convert this to a range. Oh, it starts an unspecified point in time. Actually, gotta check. Is it always positive? Otherwise it can cause trouble. So I can tell it that I want it to be millisecond. So we could set it in state so it knows where it started from. That will give us essentially a 0. Actually, no, like we can just shove it in. Do we have sign? We have to sign. Okay, math's in. That's good. So because we want things to fluctuate up and down, we work with time. So in increasing time is very useful. Where was I? Down here somewhere. So we can take that time and we can shove it into math.zin, which should give us a number between 0 and 1. Imagine. And we can, so let's call that shift. And we want to turn that into a hue. So we take that number between 0 and 1. I'm not mistaken. And we times it by 360. That should put it in inside the color space. And now we just set the lights to that hue, and that should look neat, hopefully. With a bit of luck, it compiles. Undefined function, new colors, 108. Yeah, don't worry about that. This doesn't require any state because it's just working with time. So doing math for sort of colors and drawing patterns and stuff, that I like. That's one of the times I like math. I find it tricky because I'm not that good at math, but it's nice. Spent a good long while working with hexagons earlier this week as well. Design, math. Okay, well, hopefully we will notice when this update is actually pushed to the device, because it should start doing things. Don't know if that terminal is just a little bit crashed. Let's see if we have any errors. Nope. So we should be receiving these shift messages. Oh, every 100 seconds, that's not very often. Timer dot milliseconds that exists, right? Timer dot seconds. That's an hour, minutes, seconds. Well, it's millisecond by default, so that's it. But that's funny. Maybe it's shifting very, very slowly, and only half of them. I don't know exactly why it wouldn't hit all of them. That would be an unintended issue. Close that one. There we go. Hey, you need to sleep. You're hitting the end of the stream probably, but oh, all of them lit up at least. So I wonder if it's gonna do the thing I want it to do. Whoa. Let's yeah, just enjoy that for a moment and then realize that we really want to slow this down. This is gonna sit on my desk. It's not gonna be doing that on my desk, I can tell you that much. So the way you slow this kind of thing down is by slowing down time. So you divide. You might be seeing it now. That's there's a bit of color. So maybe we go by second. We can do that, so that could be fun. that will be nice and peaceful. If we go by second, it will slow it down 1,000 or so, 1,000 times or so. Now I'm staring at it and seeing if I can detect a change in color, because it turned still and orange. Oh, now it's shifting. Still shifting a lot, which I didn't expect. I wonder what that's about. Now it seems to be shifting slower. Okay. This sort of indicates that it's, let's see, it's making, like if I could see the curve, that would help. So a sine wave, I mean, it goes up and down, and all right, if you want to lengthen the sine wave, there's something else you could do. Oh well, it works to have it like this. But yeah, I'll probably keep fiddling with this a little bit after or later, and just make something I'm happier with the exact result. But this is neat. I mean, it is working along the color curve. It's just not doing it very nicely right now. And it's time for me to wrap up. So thanks everyone for watching, and let me know what you would like to see in one of these things in the future. I feel like we're done with this project for now. It can do all that I require of it, which is good.